Okay. Let me, Thanks for inviting me here today. I'm transforming the system that just transported me out here. And I want to introduce Loomo, the robot from Segway, that's going to be my assistant for this keynote.
Hello, everyone. Nice to be here.
Before we get started, hey, Loomo, how about you go get me some water?
Sure thing. Brian, be back soon.
Okay. As I said, really excited to be here. As was introduced, it's my birthday, and I can't imagine a better way to spend your birthday than flying drones. Just a reminder, for those who haven't seen one of my keynotes before, everything we do is live. It's a real demo. It's not a canned, videotaped prior thing. So if there are some mistakes or some issues, just understand it's real technology. Now, let's get started. And I think I forgot my clicker. So what better to do at a drone show than to have your clicker delivered by a drone? Okay, so ready? 3, 2, 1. Told you it was all live. So I want to show you today how really technology is disrupting industries where automated systems are being used. And we're going to have a really good discussion, I think, about just what's happening in the industry. I'm going to focus on 3 things today as we go through this talk. First is what we call data is the new oil. And I'm going to explain to you what that means. But think about what oil did to society, to culture, to almost everything we know back around the turn of the 1800s to 1900s. It really, everything we know today was really transformed and became what it is as a result of oil. And data is going to be that replacement, is what our belief is. Second thing is automated systems on the air, in the air, and on the ground. We'll have some really good time. We'll fly some things. We'll ride some things around like I just did. And we'll show you just what's possible. And then really the power of these connected systems. What happens when you take those autonomous systems, those systems that are out there, and you connect them and they provide data, and you bring that data back. And that's really how you connect back to that data is the new oil. So let's begin with this first topic. Let's begin with just how data is shaping the future of technology. So data, is our belief, has become one of the most important forces in all of technology. Or as I said at the beginning, it's really become the new oil. And it provides insights and opportunities to everyone who wants to better understand their industry. And we believe that the world will become separated over time by those who have data and use data and those who don't. And those who don't will fall behind. And you can pick almost any industry you can think of. Even retail stores where you buy your clothes, they're going to be separated by data. And you can already see they are. The online people have data that the brick and mortar people don't. And data is separating even the retail industry. As the world becomes smart and connected, and we all see that happening in our homes, in our workplaces, in the automobiles we drive, everything, the number of devices connected to the cloud is exponentially increasing. You can think of them as those oil wells out there pulling up the data and extracting it, allowing us to have insight into it, and bringing that back into the cloud and giving us the ability to apply analytics to it. The result of all this is a data explosion like we've never seen. And oftentimes when I'm talking to analysts and other industry experts, they tell me, isn't the amount of data about to peak? And I always remind them, no. And in fact, the future of data is much, much larger than what you can imagine today. So I try and bring out some good examples. By 2020, there's going to be incredible amounts of data that are going to be produced by all these connected things. And one of the ones I like to use is a single autonomous vehicle. A single autonomous vehicle will produce about 4 terabytes of data during a 1 or 2 hour drive. Now, for those who have driven an autonomous vehicle, and I've done it for a couple weeks, it's amazing. I mean, literally, I have these 4 terabyte drives, and I have to replace them every other day just driving to and from work. It's the data that's being collected and the mapping and the collection of really what's around it is huge. Now, how does that compare to the average person? The average person today puts out about 650 megabytes of data. By 2020, the estimate is that'll be about 1.5 gigabytes of data. Now, that puts the average autonomous car equivalent to about 3,000 people. So, put 1 million cars, put 1 million autonomous cars on the road, and you've increased the data load onto the internet, into the system, into the world for which you can now apply analytics to, by roughly half the population of the Earth. That's just 1 million cars. So you can imagine what's going to happen as this data explosion occurs, the kinds of industries that can be formed around this. If we take a drone, for a single drone flight, the estimate is about 50 gigabytes of data can be collected by a single drone. Now, since drones can fly multiple flights per day, and most of that data is using today's mostly visual optical data, this translates itself, again, into terabytes of data on a daily basis from drone flights. So you can see whether you're using how people are going to grow in their data usage, something like autonomous cars, something like autonomous vehicles like drones, to factories, the data rate is going to explode on us over the next few years. But this is an opportunity, not a problem. Now, today's systems are simple. They capture data from their environment using a GPS for location, and they have some cameras on them. And there's a variety of cameras. There are high-resolution cameras and low-resolution cameras and thermal imaging cameras and all. But as these systems become autonomous, the amount of data that's going to be produced by them increases significantly. Because the sensors and the type of data that's used to make it autonomous requires that data rate. Now you're starting to include systems, not only visual systems like cameras, and you'll need multiple cameras now, but you're including LiDAR and radar and sonar. And that allows these systems to see around them. Now with Intel, we've developed technology we call RealSense, and you're going to see some demonstrations of that today. And we'll talk about just what RealSense is. But it increases the data set that enables artificial intelligence and an incredibly detailed mapping for these autonomous systems. So let's take a look at how ground-based autonomous systems are going to use this data. Now, the evolution of autonomous systems has given rise to fully and truly innovative technology advances. Cars and robots are 2 areas where we've seen some incredible progress, and we're going to talk about that now. So let's take a look at the first area, and that's going to be autonomous driving. Now, this area is rapidly evolving. Almost every day you open up the internet or a magazine and you read something about somebody making big advances in autonomous driving. And as I said earlier, I've been driving autonomous cars around in various forms for some time now with the team. And then, as I talked about earlier, the number of sensors and cameras that are on these cars is incredible. And the amount of data they generate is just mind-blowing. So I'd like to show you just our vision for what the autonomous vehicle is going to look like in the future and how it's going to be processing data and interacting with its surroundings.
For more than a century, the evolution of the automobile has stirred our imaginations and ignited our passions. But never in that long history has the industry faced a more important moment of transformation. A transformation that promises to bring a whole new meaning to the phrase. I wonder what this bad boy's got under the hood. The car of tomorrow will essentially be a data center on wheels, capturing and analyzing terabytes of data, collected through hundreds of sensors, and put to use by powerful in-vehicle processors. Of course, the technology that will enable fully automated vehicles won't be confined to just the vehicle itself. It will require a diverse array of flexible, sophisticated, and fully integrated solutions, from bumper to bumper inside the car to end of the entire automotive ecosystem outside the car. The result will be a technological wonder on wheels that leverages the intelligent use of data to enable exciting new innovations, make driving safer, and completely redefines the concept of high-performance vehicle.
So you can imagine the future of cars are not separated by horsepower, braking, those kinds of things that we're used to today. It's going to be the user experience. It's going to be how does that car use the data that it's collecting? What's your autonomous experience like in that vehicle? That's what's going to separate it out. And cars, to me, are the best example of how data is going to become the new oil. They truly will be displacing oil. Okay, so as you can see, there's a lot of sensors in those vehicles. And this is a place where technology, innovation, and policy are coming together to really ensure a safe and effective autonomous experience once you're in the car. And we're laying the groundwork today for the infrastructure to ensure that there's good cellular and eventually 5G connections so that data can get on and off that car. That's one of the most important things that has to be done. Autonomous vehicle testing on public roads is critical, we believe, to improve models, fine-tune the algorithms, and really make sure that the users have confidence in the vehicles that we're going to be putting out onto the road. And we're talking now about how do you really test an autonomous vehicle? How do you know? How do you hand it to a customer? How do you test your software improvements? Those are going to be important for the future. By 2021, we believe autonomous vehicles will be prevalent on the roads, and the infrastructure and technology innovation that we're making today as an industry are truly going to make this a reality. This is coming. And for those of you who have driven in an autonomous car, once you've done it, you never want to go back. So let's take another look now at some other areas of innovation, and let's move from cars to robotics. The future of unmanned systems is the ability to really emulate human vision. You have to see just like you do, instantly mapping the room. Your brain and your eyes work together to instantly map a room. You know what not to walk into. You know how to make sure you get around obstacles. Even as I rode out here, I knew exactly, instantly, what the distances were, what I had to avoid. We've developed, I believe, a cutting-edge camera technology that I mentioned earlier called RealSense. And RealSense has a set of cameras that have a variety of sensing technologies. And what this allows you to do is it achieves true depth perception with 3D imaging. It can allow interior mapping, so you can map rooms inside, and feature tracking. So once you lock onto a feature, a person, a face, eyes, you can track those then. The integrated software and hardware capabilities of this camera includes what we call simultaneous localization and mapping, or SLAM. And it's developed by Intel. What that allows you to do is take those 3D images, produce a 2D map, and allows it for autonomous navigation and obstacle avoidance. And that's a critical step that we provide the solutions for you. We have systems out there today. We're continuing with a family of these. The next generation will be out in the second half of 2017. Each one is lighter, smaller, lower power, and has better distance capabilities. It really is going to allow, over time, autonomous vehicles to move at any speed, indoors and outdoors, and for them to be able to map their surroundings in an effective way. So as you may imagine, these autonomous navigation and obstacle avoidance is critical to the success of these systems. Earlier, I came out on stage on a robot named Loomo. And I asked it to be my assistant and grab some water. And you can see him coming out now. And he's doing exactly what we just said. Loomo's mapping in both 3D and then converting it to 2D, the world that is on this stage. It's using RealSense cameras in its head unit, and it was able to navigate all on its own right to the center of the stage.
Here I am.
Well, hi there, Loomo.
Hi, Brian. I brought you the water you asked for earlier. You can use your phone to unlock my delivery container.
So I have this phone. It has a 2D code on here. Now I'll go up to Loomo. He's mapped his way out here. That will open up the back door. My water's in there, thank goodness. And off he goes.
You are welcome. Let me know if you need anything else.
Okay, Loomo. So now he's going to map his way, just like he did out here on the way out. And you can see from the maps there, the one on the left is the 2D map that it's used SLAM to convert the 3D images on the right to really map exactly what's on this stage. So nobody was back there guiding that vehicle back here. That was truly an autonomous system navigating this stage and how you're able to see the same images. Now, if you're interested in learning more about the Intel RealSense platform and how it'll enable this 3D depth mapping and navigational solutions, you can stop by the Intel booth in Hall D at the Expo Hall, and we'll show you everything that there is for that. And we're really trying to make this so that you as a developer don't have to worry about the depth sensing and the software capabilities. We're trying to provide you that output so you can really focus on your product and what you're trying to deliver to the market in an autonomous mode. So for me, it's exciting to see where we've come in the last decade. And the next decade, we believe, are going to have massive innovations. Things like RealSense will become so small, so low power, they'll be in everything, allowing it to map and understand the environment. Even something like your refrigerator is going to have eyes that look out and understand who's in the kitchen. Does it need, what kind of power level does it need to be running at? Is the door likely to be open soon because there's people in the kitchen? Everything's going to use this kind of awareness data, help it understand and become more autonomous, but really become more smart. Autonomy is really about having intelligence and having the ability to make decisions. So let's shift our gears a little bit and our altitude and talk about aerial systems. And as I said, we're going to do everything live here today. So we've got some fun surprises for you. So for us, drones are becoming more and more mainstream with really ever-expanding use cases. And to me, it's amazing. Every day I see new use cases that are being advanced by the industry. I thought, well, let's take a quick look at a video that shows us how the drones and data are coming together to really realize the future.
The dream of flight, from the Wright brothers to Sputnik, to the interplanetary mission known as New Horizons. The human drive to explore our world from above has driven the continual innovation in the technology of flight, both manned and unmanned. Already, UAVs have made the leap from the realm of science fiction to being an everyday tool of the trade in a diverse array of vital industries. From agriculture to construction to infrastructure inspection, even entertainment. And thanks to continuing advances in the effectiveness of onboard compute, camera and sensor capabilities, and automated flight control, the era of true autonomous flight draws closer by the day. Commercial-grade, multi-rotor platforms like the Intel Falcon 8 Plus offer the robust reliability, safety, and maneuverability required by even the toughest assignments, while fixed-wing solutions provide a highly productive means to capture detailed data along large-scale linear structures such as pipelines, railroads, and telephone lines. And soon, the development of entirely new hybrid form factors will combine the best features of multi-rotor with the productivity and longer flight capacity of fixed-wing UAVs in a single unit that can do it all. Most exciting of all, the coming integration into UAVs of other key technologies driving the data revolution, from 5G to predictive analytics, machine learning, and more. All of which positions the UAV industry as the place where the next wave of innovation is taking flight. So, if you want to get a glimpse of the future, all you really need to do is look up.
Okay, so we talked about the amount of data that these systems are going to be producing. And they can, as I said, create 50 gigabytes a day of data. If you think about it, an average drone maybe produces 500 images on a flight. Each one of those images, 30 megabytes if it's a high-resolution image. If you have a fleet of 500 drones out flying on any one day, that's 150 terabytes of data that's going to be produced by a relatively small commercial drone fleet. So rather than just talk about this, though, this is where the fun is going to begin. Let's take a look at one example of how innovation in drones is really changing the technology. In the video, you saw examples of how drones are game changers for industries like agriculture and oil and gas and construction. And today, I'm excited that we're going to be able to demonstrate how automation, which is one of the most compelling and new capabilities we see for the future of these autonomous vehicles, is coming to life with inspection applications. So automated flight will provide a leap forward, a huge leap forward in the productivity and really the usability of these commercial drones, especially in areas such as infrastructure inspection, things like cell towers, oil rigs, and as you look to your right, bridges. So we brought a bridge with us today. I'm sure all of you travel with a bridge. Now, a typical inspection to a bridge like this is going to require either several people, many hours, probably days, to inspect all of the surfaces, and especially if we expanded this into a real, much bigger bridge. And the ability to get underneath, whether it's over the water or even worse, probably over an active roadway, and inspect the underneath with any kind of detail, is quite difficult. And if you take a drone out and you use a pilot, again, you have the ability, the requirements to really understand and have precision flying to be able to do that inspection. With Intel's innovative mission control software, this process can be completely automated with a single tap on a tablet to engage the drone. So, to show us just how this all works, I'd like to invite Dr. Marco Mueller from Intel's drone team to come on stage and show us how to do an inspection of a bridge. Hey, Mark.
Hi, Brian.
How's it going?
Good.
Okay, so we got our bridge. You got a couple computers here.
Yep.
Tell us what we're going to do. How are we going to fly?
Yeah, actually, we will see an inspection of this tiny bridge over here. We have the Intel Falcon 8 Plus and Intel Mission Control, and that I will demonstrate to you. In principle, you will see 3 steps. That's flight planning, flight execution, and quick data check. So should we start with planning?
Sure.
So let's go to the tablet. We have to select the hardware type we want to use. That's the Intel Falcon 8 Plus. To select what type of object we want to map. In this case, it's an object surface of this 3D model. Select roughly where it is. The resolution is already set up to 0.8 millimeter. That's the ground assembly distance. Done, flight plan is computed, and I send it to the UAV.
So each one of those blue dots is where it's going to take a picture.
Yes, correct.
And now the Falcon 8 Plus has obstacle avoidance too. So even if something happens, wind gusts or something like that, it will control a distance from the surface, correct?
That's something we have on our roadmap. Yes, that's this distance collision avoidance.
Okay.
Will come.
Okay, so how do we fly? Where's the controller?
Actually, this is a controller. So actually, you can now press launch, and then we'll fly.
That's
you
it?
want to do it?
I just get to push launch, and that's it. No big flying time today.
Yeah.
Okay.
So now the boring part starts. The drone takes off and flies, and we have nothing to do here. So for us, it's really simple. If, let's say for the operators, we put a lot of thoughts into get that working automatically for arbitrary shapes. So now drone is starting to capture images. And what you see here is that the camera is always pointing orthogonal to the bridge, so we get always perfect shots. We got perfect overlap automatically computed. The flight plan is pre-checked in front of the flight, so for safety, that we're not colliding with the bridge, for data quality, that we have perfect data set, and for airspace compliance, that we're not flying in restricted airspaces or flying too high. And all this is taken into account the hardware we are using, the camera we are using, and we can do this not only for this copters, but also for fixed wings. Intel is also offering, and this all with a simple tap.
So as a bridge inspector, the inspection is really break time almost. You could just
yes.
take your lunch hour now. So I mean, typically this would take hours, if not days, for a human to inspect.
Yeah.
The normal inspection of this kind of surface would be how long?
So we captured, I think for a human it will take days for big bridges. We are only capturing portion of the bridge right now. We did the entire bridge yesterday, what was about 15 minutes or 1,000 pictures. It's only that long because we captured it was 1 millimeter. If we would go for centimeter, it's only a minute.
Got
and
it.
now we're about to land, and the data transfer is started automatically. And we will get all the data downloaded to my tablet over here. And I will show you the entire data set we captured yesterday on another machine. It's over here. So you see all pictures are georeferenced around the bridge. So it's automatically checked for coverage and for quality. And we can even, let's say, zoom in and just take a look at some of the pictures. Let's take that one. And zoom in, and wow, we found our first crack. And I think no one in the audience has seen the crack before. So that's something we can immediately see on site seconds after landing without making big processing first. So it's a really good tool to get people a first insight in the data set to make sure that they captured everything in a good quality.
Right.
So with a simple click now, we can hand over this data into processing. We're supporting several tools. Today I will show you context capture from Bentley systems. We process the data set, and this is what turns out. The bridge in full 3D. We can go around. We can go into details. We can even go below the bridge and see another crack.
Now that's pretty unique, right? I mean, for a drone to be flying under and capture the images above it, that's not an easy task to do.
That's not an easy task. And so as an operator, if you want to measure such a crack, you would have to climb or need some other equipment. So here I can simply say, OK, I want to have distance from here to here, which is about 4 centimeters wide. That's even more than the crack. So you can simply measure things just in a Swift, and you can georeference them and later on send the repair crew to exactly that spot. You can manage your assets. If you have more than one bridge, it's a big data task again.
Wow, so fully automated flight, data upload, it then builds the maps. It allows you to go and inspect. You can then send a report back with the exact locations for which they need to go do the repair. It really is an automated system for inspection now.
Yeah, and we are planning to release this later this year, so in the second half. So yeah,
great.
Let's stay tuned.
Thanks a lot for showing us. Thanks, Marco, for doing this.
Thanks, Brian.
Now, another unique thing about that demo that I didn't make much comment of is it also uses some unique Intel technology. Clearly inside this building, there's no GPS signals available. And there were no infrared motion sensors or other optical systems over there tracking the drone. So Intel's developed unique technology capabilities to be able to pilot and navigate drones indoors in a non-GPS environment. And we work with partners to provide that capability as well to you. So that's another option you can talk to us about how do you fly your drones indoors if you need to do inspections inside large hangars or other kinds of work environments, factories, things like that. So for us, the Falcon 8, which you just saw, we're continuing to push the technology of that drone platform. The Falcon 8 Plus that you saw, the payload is already switchable. We understand customers want to have a variety of payloads. We're also making possible the ability to put your own sensors on there. And we'll provide open APIs that allow you to connect your own sensors and push that data through the hardware and out to the outside world, just like any of the sensors that Intel would normally provide. And that's an important aspect, we believe, to really allow innovation and new capabilities on this kind of platform. We want to provide platforms that allow developers to really expand the usage cases. Now, all of that comes with that automation software and the ability to fly in an automated mode. And we really believe this will provide the flexibility to optimize the drone for the user's needs. Okay. The Falcon 8 Plus you saw just over there will be ramping in production. It's available in North America already. You can put orders in place, and you'll see more and more capabilities as we go through the year. Okay. Along with bridge inspection, we've also been working with AIRBUS. And with AIRBUS, what we've been working on is using that same technology, same Falcon 8 Plus drone, that indoor precision mapping capability so that you can understand exact location of your drone. And combining that with software that AIRBUS has developed for aircraft inspection with Intel drones. And this is another thing that takes hours of time by humans, typically. Airplanes that are used in the commercial industry have to be inspected regularly for cracks and defects. And as people who fly on these planes all the time, you want that done as often as possible. And now it's a manual system with people having to climb all over the plane. With AIRBUS, we've developed a system that's capable of doing it both on the tarmac or in the hangar. And either way, they could do a full drone inspection. And again, AIRBUS in this case, we showed you one set of analytical software there for the bridge. AIRBUS has developed additional software that allows you to do airplane inspection. And again, identify defects, geolocate them, understand their size and dimensions, and then push out a data report that allows people to go back and do the repair. And as we continue to innovate these systems, the industry will benefit, we believe, from these increased customization and functionality that you'll see in the future as this open platform really adapts to your needs. Okay, so drones and autonomous cars and robots are just one of the most powerful ways we believe data is generated and used today. And we're enabling technology that is really going to push, we believe, the drone ecosystem. From our RealSense cameras that will allow for depth perception, navigation, to our Aero platform. That was the one who brought my clicker and dropped it over there. All of these are really designed for developers to really have the flexibility and freedom to do what they need to do. And as we continue to invent, we realize the future is truly in intelligence and machine learning. That the vehicle itself is going to become less and less important, and it's going to be that intelligence and machine learning. I kind of hinted to that with the cars, too. The future of how you're going to choose the kind of car you're going to want is going to be more based on the intelligence of that car than the horsepower of that car. And the same is going to be with drones. As long as it can carry your payload, you're going to look more at what's the intelligence. Now, for Intel, we're excited because we've added Movidius as part of our portfolio. And what Movidius does is it's really an industry-leading accelerator, onboard accelerator to the drone itself that provides real-time analytics, tracking, and decision-making, artificial intelligence, at the edge, on the drone itself. So you can imagine smart systems able to navigate complex terrain based on algorithms that you develop in the future. The system will be able to self-identify and self-navigate. And when we think about the future and going beyond line of sight, this kind of intelligence, this kind of capability, we believe is going to be critical for the future. This platform is ideal for that kind of application. And it's already deployed across a wide variety of autonomous systems today. And with this, we want to really fuel the creation of this new autonomous industry and unmanned systems that in order to really get out there and beyond line of sight need increasing intelligence and increasing ability to make decisions. So I would like to shift a little bit now from some demos and showing you how data and intelligence is going to get to the edge to really, okay, what do you do with these things for the societal good? How can these really help and impact human lives in a positive way? Natural disasters are disruptive and costly, and they affect almost everywhere across the planet. And flooding itself is one of the most expensive and costly and dangerous disasters, and is one of the ones that is most difficult to recover from for a society or a community. And automated systems that can provide support in these situations are reliant on connected end-to-end solutions with those same sensors and processing and cloud and connectivity that we've been talking about all morning. And we've really been at the leading edge trying to push this capability out into these disaster situations. And we believe that the future of unmanned systems is really reliant on the ability to push out there and have that connected capability. And the end-to-end solutions for search and rescue are going to be critical. So, to tell us more about just how this ecosystem is developing and how unmanned systems are helping support search and rescue efforts, I'd like to invite on stage with me this morning Texas A&M University professor, Dr. Robin Murphy. Hi, Dr. Murphy.
Hi, Brian.
Hi, welcome to the conversation this morning. So you've been involved in using robotics for disaster recovery for some time now. So maybe start with what's been your journey and give the audience some example of that.
Well, the idea of rescue robots, ground, marine, aerial vehicles, started about in the 1980s. It's just an idea. And then in the 1990s, when the ground robots that were being developed for the space program kept getting smaller and smaller, they became feasible for building collapses. Then when we got the breakthrough in UAVs around 2005, it was a no-brainer to use them at places like Hurricane Katrina.
So, okay, that's great. We can see that. So if you take a look at this as a first responder, what's the single biggest technology challenge you guys have in going out and doing search and rescue in these kinds of environments?
Well, with these types of technologies, the big challenge remains the data, because it's all about the UAV providing the right data to the right person at the right time so that they can make the right decision to save lives.
Okay.
And so what I'd like to do to help illustrate that, let me show you a video.
Okay, that would be good.
Okay, so this is Texas floods, the Memorial Day floods in 2015. Now what you're seeing is a UAV that's being used to search for over 20 people that have been swept away by the flood.
Wow.
That's the low resolution viewfinder view, right? You're not going to be able to find much of anything, a person, any sign of debris or any sign of where a person's been with that view. So of course what we do is start taking the high resolution images on board. Now here's where it really gets tricky. A single flight will get about 800 high-resolution images. Great. Now a person or persons have to look through each of those images to see for signs of a person or debris. That will take 20 to 60 hours. One flight, one day, one UAV, one subsection. If you've only got 24 hours to find somebody alive, 60 hours is a real problem.
Yeah, if that's me out there, I'm going to worry about that 60-hour time frame. So, okay, so it's clear time's a critical factor here. And you can imagine, right? If you're swept away in a flood like that, boy, every minute has got to be horrible. So how can you use emerging technologies for these kinds of large and small scale disasters out there?
Well, the data challenges and the data use is actually the same, regardless of the size or scale of the disaster. What we're seeing now is the ability to use things like the photogrammetrics that you were showing earlier with the thing. You're also seeing things like the 3D reconstruction, which can be used not just for bridge inspection, but things like the ozone mudslide. So there should be some shot of some 3D reconstruction here. Okay, so you can see, so now you're talking about acres rather than a large bridge, and that's increasing the data challenges. Once we've increased those data challenges, that pushes us to start using cloud computing. So because we need the level of compute that we can only get with that massive processing. Well, right now to do these types of things for very large scales is taking 3 to 4 days. Wow. Cloud computing can get us down to a day and a half. But as you pointed out, it's all about time. So we would like it to be really fast, like right now fast, like supercomputer fast.
Got it.
If you have supercomputer on a chip, not that I'm hitting to Intel or anything, you know, are embedded in the field, then you can start applying all these great artificial intelligence, computer vision processing, machine learning work. Like for instance, this machine learning work here, going back to those same images from the flood, the computer can use machine learning to detect signs of people or debris in 92% of the images in 90 minutes, cutting that time down. So it's now a game changer to have this type of computing, and I feel it's within reach.
I would agree. So this is incredibly exciting, and you can see everything we've talked about this morning. It's about the data, and it's about the ability to apply intelligence to that data. And I commit to you that we're going to work on that and bring that to your field of industry. Thank you very much.
Thank you very much.
Okay,
it's
Robin.
so exciting.
So you can see that it's, again, getting out there and flying the drone, capturing the images, that's not where the value is going to come. It's who can first provide that machine learning capability at the edge, and then provide in the cloud for the huge problems like the mapping of the mudslides and understanding the real movement of the earth in those cases. Okay, that needs cloud, but again, it's going to have that ability to pull that data, bring that in the cloud as quickly as you can, and process it. A comprehensive end-to-end solution is what we'll have to deliver as an industry over the next few years to really provide these kinds of really life-saving capabilities. And I believe that this industry, with partners, can go deliver that easily. Okay, so now for some more fun. We've seen a variety of different ways autonomous systems are capitalizing on the power of data to really unlock innovation and drive usage models that are today cumbersome, take long hours, and oftentimes put people at risk. These have been the more traditional, I'll call it, use cases. There's one area where we've been pushing and also seeing some incredible innovation, and that's in entertainment. Now, in 2015, we introduced what we think is a groundbreaking drone experience for entertainment in the night sky. And you may have heard about or seen one of the mini drone shows that Intel has put on with several partners around the world. But in case you haven't, I thought, let's take a look at what we've been able to accomplish in just 2 short years. So if you haven't had a chance to see one of those shows, we're going to become a little more public about broadcasting where their next locations are. But they're truly a fantastic experience. Now this is the Shooting Star drone that we've developed specifically for this experience. It's super light. It has protective cages around it to make sure that if it does come near people, it's completely safe. It's actually quite intelligent. It can produce over 4 billion color combinations with its system down below, its lighting system. And we're going to continue to innovate this. We think we can continue to make them smaller, lighter, and more intelligent, bring them the experience to even be more capable over time. And I think there'll be a time when you'll see thousands of these systems. And you can imagine their usages beyond just entertainment. We've learned a lot about what we call drone swarms by this system. Now, I couldn't bring 500 with me today. I'm sorry. I wanted to, but the team said no. But I think we can have a little fun and put on a small show with you, even indoors, using that same precision mapping technology. So let's have a little fun and put on a show. I think that's some precision automated flying, considering no GPS, no infrared mapping system, all flown unmanned. So after the show, feel free to head over to the bridge, check out the technology that you just saw. Some of the team that put on those shows, it will be over there, and you can talk to them about just how they put on those light shows. It's an amazing system that they have now. We've really, I think, come a long way in the last year on this space. I hope you've enjoyed our time here this morning and talking about really the fact that this autonomous vehicle system, this world of UAVs, is going to become a data-driven world, and it's going to become more and more important of what happens to the data than the system itself. I'm excited about the innovation. I'm excited to be here this morning and share this vision with you. I was glad almost every one of the demos worked perfectly. The only one that didn't work was me catching the clicker, so the human was the only part that didn't work today. Thank you for the time this morning, and thank you for listening to me. Thanks.